This holiday, BMW has reunited 3 members of the family at the BMW Road Home Sales event. The Agile X3, engineered for any adventure. The plug-in hybrid X5, commanding the streets with unmatched presence. And the all-electric i4, charging into the future with impeccable performance. Hurry in to find what powers your journey at the BMW Road Home Sales event. BMW, the ultimate driving machine.
Visit a Valley BMW Center today for attractive lease and finance offers.
You can have it all. Great pay, awesome benefits, a flexible schedule, the chance to grow. At Cox, we're recruiting auto and diesel technicians to join our Mannheim and Fleet Services teams. If you're ready for a new job and want to experience an award-winning workplace, drive your career forward with us. Visit cox.career/autotech to learn more. That's cox.career/autotech.
Hi there, thanks for joining us. This is Space Nuts. My name is Andrew Dunkley. This is our final fresh episode of the year, and I'll tell you what we're doing at the end of the episode over the Christmas New Year period. But it's a Q&A episode, which means we'll answer audience questions. We'll be basically focusing on Dyson spheres today. We'll be getting a question about the dark matter effect, as a matter of fact, and black hole effects and time distortion without gravity. And if you can chuck anything else in, we will, time permitting, on this Q&A edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And for the last time officially this year, we welcome Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Good to see you again.
You too.
Really been missing you.
It's been so long. But yes, it is our final episode of the year, and we've got all audio questions today, and we'll try to answer one or two of them. It's been a busy year. There's been a lot to talk about, some amazing discoveries, some mysteries that continue to elude us. And that's what tends to spawn most of our questions, to be perfectly honest. Are you ready to get into it? And we'll take question 1.
Why don't we do that?
Yes.
Nothing else to do,
and
really.
I think all the questions come from regular contributors. Our first one comes from Mikey.
Hey, Fred and Andrew. Hope everything's well down there in the Southern Hemi. This is Mikey again from Illinois. If a Dyson sphere is a megastructure surrounding a star, how does the planet get light? Or is the planet inside of the Dyson sphere as well? And if the latter is the case, do you just prevent every other planet that's already in that star from receiving any light, heat, and energy, completely wiping out any other chances for life on any of those other planets and or moons orbiting it, like Europa or Titan here? I mean, if I'm thinking of this right, if a Dyson sphere encases the sun, how is life going to get a chance without any heat or sun or any type of energy from that star? Anyways, just trying to wrap this all around my head. See what you guys think. Thanks.
Thanks, Mikey. You make it out of perspex, Mikey. That's really the solution. I don't know. It's a really good question. I haven't really thought about that side of it. If a civilization had enough technology to build a Dyson sphere and harness the energy of their solar system's star, what happens to the light and what happens to the planets that are reliant on that light and that energy that's being mopped up by an object that's basically surrounding the sun?
So that's the I guess the misapprehension that most of us have on what a Dyson sphere is. Because Dyson himself didn't envisage that. I haven't read the paper, actually. It was published in Science back in 1960. It's called Search for Artificial Stellar Sources of Infrared Radiation. What he's saying is that if you've got a structure built around a star, because you've got such an energy-hungry civilization, then you basically, you build things around the star that collect the energy from the star and turn it into electricity, but they would naturally re-radiate the excess heat in the infrared. And indeed, he's suspecting that it would be perhaps the far infrared, longer wavelengths. So and his proposal was that would be a far infrared signature around a star that you'd expect to be just pumping out visible light would suggest that there was some sort of structure around it. Now, there is a quotation that I'm reading from Dyson himself, who says, "A solid shell or ring surrounding a star is mechanically impossible. The form of biosphere which I envisaged consists of a loose collection or swarm of objects traveling on independent orbits around the star." And that's basically the bottom line, that the Dyson sphere isn't really a solid sphere. It's a region around the star where you've got many objects in orbit, in independent orbits, which are turning the energy of the star into electricity. So you're not harvesting all the light of the star. So Mikey's question is one that I hadn't really thought about before, but is almost directly answered by this, because you still have some of the radiation of the star that's leaking through, coming between the swarming objects. It's not leaking, it's probably by far the bulk of that material. But you're adding to the light of the star this far infrared signature that tells you that there's objects around the star that are artificial. And so you could probably put it wherever you want. I would guess a Dyson sphere around the sun would be a swarm of objects, perhaps even inside the orbit of Mercury. And so there would be a slight reduction in the amount of energy going out to the rest of the solar system, and it might be one of those things that would modify the climate of habitable planets like Earth, but it wouldn't shut down the light of the star altogether, because you can't do that. It's mechanically impossible, as Dyson said.
Yeah, it certainly makes more sense when you explain it that way, and it's not dissimilar to what we're doing around the planet with communication satellites. I wonder if an alien species observing our planet from afar could detect that something's a little bit off because of all the satellites. Would that be possible, do you think?
It would be. Well, there's enough, just straightforward radio radiation leaking from the Earth that would be detectable by certainly by a civilization having similar facilities to the Square Kilometre Array, which we have. The Square Kilometre Array claims that it will be able to detect an airport radar at 50 light years. So that's telling you that our airport radars will be detectable by somebody at the other end having the same sort of equipment.
Wow.
Yeah, so it's so we've already given away our presence in a cosmic sense, and I mean, it's often quoted that the first high power radio broadcast that was made from Earth was the 1936, was it, Munich Olympic Games? That was broadcast around the world, and so there's a gentleman, wasn't really a gentleman, and that's saying a lot of things loudly and with force at that time in his speeches. His voice will be the one that will go all around the local environment of the sun, and make any alien not want to come here, I think.
Well, that was portrayed in the movie Contact with Jodie Foster, where the return signal from the alien species was images of the Nazis at the opening ceremony of the Olympic Games. So, yeah, it was well used, very well used in that film. But in terms of a Dyson sphere around a star, not a solid object blocking light, but multiple objects collecting. What did you say, on the infrared spectrum? And
far infrared. Yeah. Well, re-emitting it as far infrared. That's right. They're collecting the visible light and re-emitting it as far infrared. So it changes the spectrum signature of the star, and that's what Dyson's paper is about.
All right. So nothing to worry about, Mikey. Nothing to worry about. It's all good. Thanks. Thanks for your question. Our next question comes from Bill.
Hi, this is Bill, San Francisco Bay Area. I appreciate you guys answering my last question, which was, can dark matter be thrown out of a galaxy and travel through space through some sort of gravitational event? So I give you a A++ and a gold star on that answer. Good job. And my next question is related. If there was a glob of dark matter floating in space and I got too close to it in my spaceship, would the dark matter's gravity pull me in and hold on to me and not let me go? So that's my question. Love the show. Thanks.
Okay, thank you, Bill. We'll be in San Francisco in a few months, Judy and I. So we were going to go there once before, but we didn't. But we regretted that, so we're going to go back. The effect of dark matter. If you're in your spaceship and you hit a glob of dark matter, or you're in its proximity, are you stuck? I suspect not.
No, I don't think you would be, Andrew. I think you're right. Because we've got, we did some work on the RAVE project, which I was involved with back in the early 2000s, which looked at the minimum size of a dark matter blob, because we were measuring the velocities of stars. And if you've got blobs of dark matter, you would expect that to be revealed in anomalies in the velocities of stars. And we didn't see any anomalies. And I think that meant that you don't get dark matter blobs less than, I'm trying to remember the number, I think it's about 100 light years or thereabouts. Should go back and look through my stuff. But you're talking about very large lumps of stuff being the minimum quantity of dark matter, because we don't really know what it is. We don't know how it reacts with itself. But we believe that dark matter doesn't clump on those very small scales. And so you probably wouldn't notice it in your spaceship. Probably, it would be such a gradual change that your spacecraft might deviate a tiny amount, but it certainly wouldn't be grabbed hold of so that you couldn't get away. So I think you're safe.
You wouldn't have alarms going off.
That's right.
The klaxons wouldn't be blaring. It would, or whatever it is they use on spaceships to tell you something's dreadfully wrong.
Or there's something like that, yes.
Yeah. So, you probably wouldn't notice anything, Bill. You wouldn't even see it. It's there. It's, we haven't even proven it, except we've proved it, or we haven't found any. Is that right? No, I don't know. It's one of those mysteries we're still working on.
We're looking for it.
Yeah.
It's yes, there are many candidates for what it might be, but we haven't found any of them yet. So
yeah.
So it's someone about because of some sort. That's the thing.
Yes, that's it. That's what's the matter. All right. Thank you, Bill. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Whatever the adventure, there's a BMW engineered to take it on. The X3 delivers a striking design with agile performance. The 100% electric i4 packed with pure electric energy. Or the plug-in hybrid X5, an impressive, versatile SUV granting full control on every journey. Choose what powers your next adventure during the BMW Road Home Sales Event. BMW, the ultimate driving machine. Hurry in for exceptional offers through January 2nd. Visit bmwusa.com for details.
You can have it all. Great pay, awesome benefits, a flexible schedule, the chance to grow. At Cox, we're recruiting auto and diesel technicians to join our Mannheim and Fleet Services teams. If you're ready for a new job and want to experience an award-winning workplace, drive your career forward with us. Visit cox.career/autotech to learn more. That's cox.career/autotech.
Roger, you're loud and clear here also.
Space Nuts.
Okay, our next question, Fred, comes from Sweden.
Hi, Fred and Andrew. Åke from the west coast of Sweden here. I have yet another question about black holes. Is it true that space and time switch roles the moment you pass the event horizon? And if so, Does that mean that space can go only in one direction, in one dimension, towards the center, hence being the reason why nothing can get out? And does it also mean that time can go in any direction inside the event horizon? Thanks. Love the show.
Thanks, Orky. Lovely to hear from you. West Coast. Is there an East Coast of Sweden, Fred? I have to look at a map.
Certainly is, yeah.
Okay.
In fact, it's mostly...
Forgive my ignorance, but I've never been to that part of the world. Yeah. Oh, sorry.
Yeah.
All right. So
we'll be up there next month. Month after.
Oh, lovely. All right. Well, we'll be up around that way in July, maybe, July next year, I would think. I didn't, I've now forgotten this question.
It's about time and space interchanging on the event horizon. And unfortunately, I haven't had time to look at these questions in advance because I just had too much to do. And so that is one that I would need to follow up in a bit more detail. I've heard the same thing, but I don't really know the physics of it. Just let me check something here, Andrew.
I love it when we do this. Just finding the answer on the fly.
Well, it's good if we can.
It doesn't always work.
So here we are. There's a nice question on the physics stack exchange, which is, are space and time interchangeable? Yeah, and it's quite hard to tease out what's fact from what's fiction.
Right.
It is all about. There's some equations I recognise there. That's lovely. There's a metric for special relativity there.
I often recognise equations, and I quickly turn the page.
Well, this one, yeah, I used to put that in talks, that particular one. When c squared dt squared plus dx squared plus dy squared plus dz squared equals ds squared. There you go. And that's basically it's the special relativity way of interchanging space and time. It tells you that time is a dimension just like space. But that's not what Oki's question is, which is specifically about how it behaves in the vicinity of a black hole. And I would need to follow up a little bit more detail on that. So apologies for the fact that that there's been so much going on in the last few days that I haven't managed to get to that one.
That's okay. We'll put a pin in that one, and we will get back to Orky in the new year.
We'll have an episode in early mid-January, I think, where we can perhaps discuss that. So I'll put as you said, I'll put a pin next to it.
All right. And I'm going to use a Stabilo Boss highlighter and mark it as homework. There we go. Done. All right. We won't forget your Orky. And if we do, just send us a note and say, hey, Buffheads, you forgot my question. We'll get back to it. We've got one final question, which is not unrelated, actually, Fred, in terms of topic. This one comes from one of our regular sender-inners. Here is Buddy.
Hello, Space Nuts. This is Buddy from Oregon. We've been thinking about time distortion and gravities. If in our space, or say there was no gravity, but there was the time distortion, okay, what do you think that would feel like? Seems like to me like there would be some kind of drag from the slower end of things, slower on the time moving things. And I'm wondering if you work that out, that drag could actually be gravity. All right. Thanks, guys. Love the podcast.
Thank you, Buddy. He's always got a bit of a curveball for us, has Buddy. Time distortion without gravity ultimately being gravity, I think was what the guts of his question was. And yeah, look at that.
Well, let me start, because that's exactly what Einstein's thinking was when he formulated the general relativity theory. But you've got to remember that there is time distortion in special relativity, which has nothing to do with gravity. Special relativity is the theory that says as things move, as they get nearer the speed of light, all kinds of weird things happen. And time dilation is one of them. Your time system changes from the observed person to the person being observed. They've got different time systems, and that's just because of movement. It doesn't have gravity in it at all.
Right.
So Buddy's right in that regard. But what Einstein then thought about was how that idea impacts on the gravity that we experience. He didn't. He basically didn't think of it as a drag, but his thinking was what we call. He dreamed up something that we now call the equivalence principle, which says that gravity and acceleration are the same thing. Buddy's right. A drag, which you might think of as a deceleration, is gravity. Gravity and acceleration are the same thing, and that's what allowed him to arrive at the general theory of relativity, because it turns gravity into a geometrical phenomenon, which we can understand. We've got the mathematics to understand geometry in something called Riemannian algebra. Riemannian manifold is the mathematical shape of space as affected by gravity. It twists and turns as you put matter into it. And so general relativity is a geometrical theory, and acceleration is part of that geometry. So basically, Buddy, that's what Einstein worked out, and that's what gravity is. It's an acceleration. But we still don't really understand it. What you're saying is it is identical to acceleration, and that equivalence principle, by the way, has been demonstrated with an accuracy of something like 1 part in 18 billion or something like that. It's a hugely accurate equivalence, gravity and acceleration. We are told by Einstein that he imagined himself when he published the special theory of relativity, he was trying to think how it would affect gravity, and he imagined himself jumping off a building and realized that he would be weightless as he fell. That, if he had coins or keys in his hand, they'd float out of his hand, his pipe would float out of his mouth, all of that sort of thing. And that was what led him to the equivalence principle. He called it the happiest thought of his life.
Wow.
That gravity and acceleration are the same thing.
Incredible, yeah. It's the sudden stop at the bottom that made the big difference there, though.
Well, yeah, you don't want to carry the analog too far, and he didn't do it. He didn't try it out in reality. But it's what I always tell people: when you're on a trampoline, when your feet are not touching the mat, when you're in the air, you are as weightless as you are in space. You've cancelled out gravity because the acceleration is cancelling out the gravity perfectly.
Yeah, it's a fleeting moment of joy. That's what you call it.
That's right. Yeah.
Thank you, Buddy. Great question, and I love where your brain goes. I mean, you've got a very sharp mind, Buddy. It's a delight to hear your questions.
Whatever the adventure, there's a BMW engineered to take it on. The X3 delivers a striking design with agile performance. The 100% electric i4 packed with pure electric energy. Or the plug-in hybrid X5, an impressive versatile SUV granting full control on every journey. Choose what powers your next adventure during the BMW Road Home Sales Event. BMW, the ultimate driving machine. Hurry in for exceptional offers through January 2nd. Visit bmwusa.com for details.
When you work in tech at Cox, you get to do meaningful work every day. You get to be the biker who codes as fast as he rides, crafting advanced tech solutions that transform car buying, or a guitarist who develops harmonious apps and websites, connecting people to people and businesses, all in real time. A savvy soccer mom running solution sets as passionately as she runs gameplays. Be the super secret keeper, designing cybersecurity systems to protect private data and websites. A planet protector, expanding EV battery life and inventing more ways to build a better future for all. When you work in tech at Cox, you get to do career-defining work that solves the greatest problems of our time. Join us and connect to work that improves lives, including yours. Learn more about our family of businesses at cox.career/tech.
Okay, we checked all 4 systems and skiing with a go.
Space Nuts.
A question without notice. Fred, your moment of the year, astronomically speaking. What do you reckon?
Oh, gosh.
What tickled your fancy? I'll give you time to think, but I just did a bit of a search on Google about the biggest astronomy stories of 2024. Artemis 2 is up there. The discovery of ultramassive galaxies. There was a story about a white dwarf. And major events like the total solar eclipse in April and a few other things that popped up during the year. Those were probably the stories that got the most headlines. It doesn't necessarily make them the biggest stories of the year. They were probably the most published from what I've gleaned. Anything stand out for you?
Well, yeah, several things actually. Yes, the eclipse was fantastic. On can't remember. It was in April 6th, I think.
4th, I think.
4th.
Hang on, let me check.
Yeah.
Hang on. It was
from
the 8th. Was the 8th of April.
Yeah. So that was fantastic. But eclipses are every year or so you can see a good eclipse. This particular one was particularly good. It was a 4-minute long eclipse, which is long. But a couple of months before that, a 1 in 20-year event was the auroral display on the 20th of May. Was it? No, 10th of May, a 20-year event. And I saw the one 20 years ago because I could see that from the centre of Edinburgh. But unfortunately, the one this year I didn't see because, like you, we were under cloud for weeks at a time. The discovery of the year, though, I think it could be something we talked about in the last episode, the fact that it's beginning to look as though dark energy is not constant. That could be a Nobel Prize winning discovery eventually. So yes, that's a big news story.
Yeah, it's huge. It is a huge story. All right. Fred, that brings us to the end of the year. I'll just tell people what we're doing over the next few weeks while we're away. We'll be digging up stories from the archives. Yes, we've been around long enough to have archives. So we'll be talking about the first James Webb images, the first image of Sagittarius A star, those moon samples that they took 50 years to open. Remember that story? Exoplanets that rain gems. There's a story in there about dark energy, surprisingly enough, and NASA with its big warning about the rising sea levels and the effect the moon will have in conjunction with that on tides. That was a massive story, which we did more than 3 years ago, but it still applies. So those stories, plus some updated news coming from one of our colleagues on the end of episodes over the Christmas New Year period, and we'll be getting back together mid-January with fresh episodes and that little bit of homework for Orky. In the meantime. Before we finish, I've got to say some thank yous. First of all, thank you to you, Fred. You are amazing. We love you dearly, and it is such an honour to have you on Space Nuts and have been doing it for so long. And, it's just terrific, and people really appreciate it, especially me and Hugh.
Thank you, Andrew. Likewise, your efforts and Hugh's efforts behind the scenes often go unseen.
He doesn't do anything.
I know that,
but you don't go there.
But you are the consummate professional when it comes to interviews and broadcasting, and it's a pleasure to work with you as always.
Thanks, Fred. And I know it's by the time this episode goes, you'll have already had your birthday, but many, many happy returns for your birthday. Which was sometime in December-ish. Yeah. I would also like to say thank you to our audience, because without you, we'd be nothing. And you are one of the most dedicated audiences I've ever had the experience to work with or for, and we really do appreciate and all your support. Our patrons, we love you. Thank you for putting money in the kitty. You don't have to do that. We've never asked for it, but you've done it anyway. All 400 or 500 of you. Incredible. And our sponsors, of course, we love them because they keep Hugh's Maserati going, that's what it's all about. Yeah. And from me, it has been a great pleasure this year. Looking forward to your company in 2025. Can you believe we've reached that year? Good grief.
Quarter of the century. It's unbelievable.
It is. Thanks, Fred. Farewell. We'll have a great Christmas, New Year. I know this is probably going to go to air after that, but whatever. And we will, no, it won't. I don't know. No, just before. It'll be next week. Next week, Christmas. I had it all on a calendar. I've lost the calendar. But, that proves I need a holiday. Take care, Fred, and love to Marnie and everybody, and we'll see you soon.
Sounds great, Andrew. Same to you. Thanks very much.
Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio for his tireless and invisible work getting this together, because he really does work very, very hard, and that is no joke. And from me, Andrew Dunkley, thank you again for bearing with us for another year, and we'll see you in 2025. Take care. Merry Christmas, Happy New Year, and bye for now.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
Whatever the adventure, there's a BMW engineered to take it on. The X3 delivers a striking design with agile performance. The 100% electric i4 packed with pure electric energy. Or the plug-in hybrid X5, an impressive, versatile SUV granting full control on every journey. Choose what powers your next adventure during the BMW Road Home Sales Event. BMW, the ultimate driving machine. Hurry in for exceptional offers through January 2nd. Visit bmwusa.com for details.
You can have it all. Great pay, awesome benefits, a flexible schedule, the chance to grow. At Cox, we're recruiting auto and diesel technicians to join our Mannheim and Fleet Services teams. If you're ready for a new job and want to experience an award-winning workplace, drive your career forward with us. Visit cox.career/autotech to learn more. That's cox.career/autotech.